This is it, the last section of MAT 0018. Here we go. We are talking about ratios, rates, and proportions, and our objective is to recognize proportional relationships and to solve problems involving rates and ratios. So a ratio is a comparison of two quantities with the same units, and the comparison can be expressed with the word to or a colon, but usually it's written as a fraction. And a rate is a comparison of two quantities with different units. So a ratio has the same units and a rate has different units. Okay, so for example, a rate would be miles per hour. Different units there, miles and hour. Heartbeats per minute. Heartbeats is different than minute. Okay, and a proportion is when you have a pair of equivalent ratios or rates. So you're having two fractions that are set equal to each other. Okay, so for example, 4/9 and 8/18 is a pair of equivalent fractions. So this is a proportion. Okay, and an easy way to check that these are equivalent is to check their cross products. If I multiply across 4 times 18, I get 72, and 8 times 9, I also get 72. So I know that these two fractions are equivalent, and because their cross products are the same. Okay. Here's another example. For every 4 apples Matthew eats, he eats 9 bags of popcorn. If in 1 week Matthew has eaten 8 apples, how many bags of popcorn has he eaten? So based on everything we already know, we can set up a proportion and connect that to what we know about equivalent cross products to write an equation. So if we're talking apples to popcorn, we know that we have 4 apples to 9 bags of popcorn. It's important to line up our units here. And we have 8 apples to X bags of popcorn. Now, if we use that same idea of cross products like we did in the previous example, we can say 4 times X, which would be 4X, and 8 times 9, which is 72, and 4x equals 72 would lead us to x equals 18. So we know Matthew has eaten 18 bags of popcorn. Okay. Here's another example. A boat can travel 128 miles on 8 gallons of fuel. How many gallons of fuel will be needed to go 384 miles? So again, it's all about lining up those units. Oops. Okay. If we know there's 128 miles on 8 gallons of fuel, we want to line up miles to gallons. So we have 128 over 8. And now it says how many gallons of fuel will be needed to go 384 miles. So 384 is going to go on the top because it's miles. We don't know the gallons, so it's going to go on bottom. Now again, if we follow that idea of cross products, we're going to have 128x. That arrow was huge, sorry. And we're going to have 384 times 8, which is 3,072. And we're going to set those two cross products equal to each other. So we have 3,072 equals 128x. Now to solve this, we're just going to divide both sides by 128. And we end up with 24. So we need 24 gallons of fuel. Okay. So it's really important to make sure that you're lining up your units on all of these rates. Okay. Here's the next one. If it takes 18 pounds of fertilizer to cover 54 acres, how much land can be covered with 42 pounds of fertilizer? So I want you to pause this one, try it on your own, see what you come up with, and then match it with mine and see if you came up with the right answer. How's 126 acres sound? If you got that, nice job. If you didn't, try to go back and see where you made your mistake. Okay. So we're even able to apply what we know about proportions to an example where we have more than one unknown. Okay. So check out an example like negative 24 over x equals negative 40 over x minus 4. Okay, so notice that we have variables in the denominator of both of these fractions. So when we do our cross products here, negative 24 times x minus 4, that negative 24 belongs to the entire x minus 4, and we need to make sure that we distribute it to both pieces there. So we need to make sure that we end up with negative 24 times x, which would give us negative 24x, and negative 24 times negative 4, which would give us a positive 96. And then our other cross product is going to give us negative 40 times x, which would just be negative 40x. Now from there we have an equation where we just have to remember when we have variables on both sides of the equation, our goal is to first get them onto one side. So in this case we could add 24x to both sides in order to get them all onto one side. And we would end up with 96 equals negative 16x, and from there we would divide both sides by negative 16, and we would end up with negative 6 equals x. Okay. If you wanted to check yourself, you can always plug that negative 6 back in, and you would find out that 4 equals 4 tells you that you did indeed get the correct answer. Okay. So let's try one of these that has variables on both sides. Okay. So we're going to start with the cross products, 5 times x minus 6. Now remember that 5 belongs to that entire quantity x minus 6. So we have 5 times x minus 6, which when we distribute will give us 5x minus 30. And then our other cross product is 10 times 2x, which would give us 20x. Okay. So now I need to get all my variables onto one side. Now, the previous example put your variables over onto the right side, which is fine. I personally typically like to put my variables onto the left side. So I'm going to bring my 5x over to my 20x, and I'm going to do that by subtracting 5x. And that's going to leave me with a positive 15x equals negative 30. And then I have to divide both sides by 15. And I end up with x equals negative 2. So once we get to the point of solving the equation, that goes all the way back to Unit 1 where we were solving equations. The new part here for us is really that cross product. Okay. So remember that proportions are similar to fractions in that we have a fraction equal to a fraction. So the proportion is really just setting two fractions equal to each other. Okay? And remember that when we're dealing with the word problems, that the difference in a ratio and a rate are that ratios have the same units and rates have different units. So typically the application problems you're going to run into are going to be rates because you're going to be talking about things with different units. Okay? And that's it for ratios, rates, and proportions. Simple, sweet, and straightforward.